What up, Mike?
Yeah, just one of those. Nice.
Like,
All right, we'll keep going with the notes. Try to get through to 3.2 today. All right, thanks for your cooperation on Friday. We had the fire drill. We had everyone accounted for except Allie, who was in the school play. How'd it go this weekend?
Pretty good.
Good. Oh, well, good. Puffs.
I tried to. I was so busy.
Did you go?
No, he did
He didn't.
I went to, did she go twice?
Yeah, with you.
I went to the first one. I go to the second one.
All right.
I remember seeing you there.
Let's go continue on the notes. Okay. All right, little review. Okay. Identifying stuff as either a growth or a decay. Okay. We have a number that's less than 1 here, so and t is positive. This is a positive. So as t gets bigger, every time t increases by 1, our quantity gets smaller. It gets multiplied by a fraction. Okay, so this is the decay. Right here, right, this base right here is greater than 1. So every time x increases by 1, our original quantity gets multiplied by 1.072. So it grows a little bit each time x increases, so it's a growth. Okay? We feeling okay? Here we go. Write the exponential function. Anyone have any idea for this one? Write the exponential function. This was in the 3.1 notes too, right? So what's the general form of an exponential function again? Someone tell me the general form. All right. Someone tell me the general form of an exponential function. Hi, JJ. You see?
Do I see?
Yeah. No, I think Alberto though. Alberto though once.
Well, lately there wasn't this.
Yeah, they're like,
I had to go find my own desk.
All right.
yeah, 'cause that's got it.
All right. We'll worry about it. We'll worry about it on Monday. Yeah. All right. So Alberto, you remember the general form of an exponential function? What is it?
Why is she sitting here? In my notes.
All right.
It's like, isn't like the thing raised to the eggs?
Yes. Close. Getting warmer.
Finish it off.
That's the one. That's the like the part I remember.
All right. You have your notes?
Yeah.
All right. Well, he's trying to find it. Jack French. What was it? A times b to the x. That was it. Okay. So then, to write an exponential function, you just need to find a and you need to find b. Okay. So let's use this first one. Let's use the initial value equals 21. Let's use that to find a. Okay. So what do I plug in? Initial value equals 21. What do I plug into this general form of an exponential? What do I plug in? So I'm going to plug in 21 for f of x. And that's equal to a times b to the what? It's my initial value. What's x equal to? What's x equal to? 0. Yeah. So then a times b to the 0 is just a. So we have a equals 21. Right. So let's plug that in at f of x equals 21 times b to the x. Okay. Then the second part, increasing at 21% per year. Yeah, so if it's increasing at 21% per year, I think it'd be 1.21, right?
Oh.
No, it'd be 1.21, yep. So increasing at 21%, if you multiply a number by 0.21, it gets smaller, right? Like if I was like 20% of my actual height, I'd get smaller, right? So if it's increasing at 21%, that means we're multiplying by 1.21 every year, okay? So b is equal to 1.21. Any questions on that? No? Okay. So if you notice, there's going to be a little pattern forming here. Okay? The initial value is just going to be equal to A. Okay? And then however much increases or decreases by, B is going to be equal to 1 plus or minus this number they give you here. Okay, depending on whether it's increasing or decreasing, okay? So this one would be what then? What's A equal to? 0.6. What's B equal to? Do I do 1 plus or 1 minus 0.03? Minus, yeah. So it's 1 minus 0.03, which equals 0.97. Okay. So every single day, for every single day that passes, my initial quantity is only 97% of what it once was. So what's my final answer?
Plug it in.
Yeah, plug it in. Yep, just plug it all in. F of x equals 0.6 times 0.97 to the x. That's it right there. Okay. Simple enough, simple enough. This one, what's my A? For part C, what would my A be, Rylan?
6.
Okay, go. What's my B, Reese? 1.5. Doubling means you go by what? If I was double my height, I'd be what? I'd be 100%. Yeah, I'd be 2. So B equals 2. But what's going on here? You guys notice this? 3 days. How do I count for 3 days? How do I count for that?
Is x equal 3?
You're on the right track. It's something to do with the x and the exponent. You're on the right track for sure. For sure. How do I deal with that? Who said that? What'd you? X over 3, yeah. Yep. So this over 3 gets dealt with. I do 2. So the initial value was 6, sorry. So it becomes f of x equals, I put a where it was, I put b where it was, and then instead of just an x, I put x over 3. Okay? Put that over 3. That's how we factor that in, okay? All right. Okay. So every time x increases by 3, this overall exponent needs to increase by 1. Okay, so if you do it over 3, put a 3 in the denominator, that's what that does. Okay? We feeling okay about that? Okay? Not too bad, not too bad. All right, what about this one? Calling cloud, what's my A?
200.
Yeah, A is 200. Okay. What is my B, Colleen?
Does it say?
Halving. We cut it in half every 6 years. So what is it? What do you multiply by something by to cut it in half?
2.
That's to double it. To cut it in half.
Like a
Divided by 2, yeah, so 0.5. 0.5, good job. Yep. And then how do I deal with the every 6 years? How do I deal with that, Colleen?
x over 6.
Yeah, you put the x over 6. So it's going to be f of x equals 200 times 0.5 to the x over 6. Good job. That's my answer. Okay, I feel like we're doing pretty well with these. All right, good, good. Awesome. Now write the equation of the exponential function containing these 2 points. All right, we did something very similar to this, right, for 3.1. So my general form is f of x equals a times b to the x, okay? So to find a, you plug in this initial, that's the y-intercept. Plug in that y-intercept point here, okay? So plugging those in, we get 4 equals a times b to the 0, which is just equal to a. So a equals 4. Okay, so we know f of x, plugging in a, we know f of x equals 4 times b to the x. Okay, then what do I do with this second point here? What do I do with that?
You also plug it in?
Also plug it in. Yep, so you plug in 5 for x and 8.05 for f of x. All right. So then how do we solve for, so now we just need to solve this equation for b. How do I do that? I got to get b by itself. How do I do that? Yes, so divide by 4. So it's going to be, so divide both sides by 4. So we get b to the 5th equals 8.05 over 4. .0125. Okay, and then how do I get rid of that exponent? What do I do? How do I make that? How do I get rid of that exponent?
You gotta do the fifth division.
Yeah, so K Phillips and Silas are on the right track. So what I need, right? I need this instead of being a, sorry, I need this exponent here, right? Instead of being a 5, I need it to be a, I need it to be a 1, right? I need it to be a 1 instead, okay? Then I would have just b, right? So how do I get 5 to be 1? I multiply it by what? 1/5, right? Okay, so what I'm going to do is I'm going to raise both sides of this to the 1/5. Raise both sides of the equation to the 1/5, okay? The left side becomes b to the 1. Do we see that? Right? 2 exponents with parentheses, you multiply them, so it becomes b equals then 2.0125 to the 1/5 is what? 1.15. We'll round it. 1.15. Okay, so that's our b. And now we have everything. We just plug the b in, and we have f of x equals 4 times 1.15 to the x. That seems like it'd be the. Are you done with that part already? Oh, nice. All right, so let's leave it there. Did I get have that part for you? Okay, here it is. Wellington's for it. Be right back, guys. Alright, yeah, let's check my work real quick. Just in case, but I think that's. Cool. Good. Good. All right, and then we repeat number 3. Okay, so we start with the general form of an exponential. Okay, to get a, we use this initial point here. Okay, so we know 3 equals a times b to the 0. B to the 0 is 1, so this is just equal to a. So a equals 3. A equals 3. Okay, plug that in. We have f of x equals 3 times b to the x. Okay, how do we find b then? We use the second point, okay? So 1.49 equals 3 times b to the 4. All right, we got to solve this for b. So we start by dividing by 3. First we get b to the 4th by itself. So we have b to the 4th equals 1.49 over 3. I'm going to leave it as a fraction for now. All right, 149 over 300. Then what do I do? How do I get b by itself then? What do I do with this? Madeline, do you know? Multiply or, well, I think you're on the right track. I like raise both sides to the 1/4.
Oh, yeah.
I think that's what you were thinking. So b, 349 over 300 to the 1/4 is, I'll just round this to the nearest thousandth, 0.893, or 839, sorry. Okay, so plugging in my b and my a, I get f of x equals 3 times 0.839 to the x. That's it. How are you feeling about that? Not too bad, right? Not too bad. All right? Not too bad. Okay, I'm sure we'll all forget by Monday, but that's what notes are for. So. check your notes. If you don't know something, read your notes. Okay. All right, write the equation of the logistic function. Awesome. Who knows the standard form of a logistic function? Anyone? What is that? BC. Like B times C to the X? Yeah, I think that's it. Good? Good stuff? Yeah. So that's the standard form of a logistic. So logistic is just an exponential, it's a function that has an exponential in the bottom. Okay. It's a function that has a logistic in the bottom. Yep. So this is standard form. Of a logistic function, right there. Do you guys do this in Algebra 2? Probably not. Yeah. This is a new concept of logistic function. Similar to an exponential, it's just like inside of a fraction, okay? All right, so to get this equation nailed down, we need A, we need B, and we need C, okay? So let's start off. Let's see what, anyone have any ideas? What should we do? It gives us initial value equals 10. What should we do with that? What should we do? So if we plug, let's see what happens, okay? If we plug in the initial value, we get 10 equals A over 1 plus B times C to the 0. C to the 0 is just 1, right? So this is the same thing over A over 1 plus B. So we know 10 equals A over 1 plus B. Okay, so we have this. Okay. Okay. Limit to growth equals 40. Limit to growth equals 40. Anyone have any idea? Okay. Limit to growth equals 40, okay? So what that's saying is that this function never gets bigger than 40. Never gives us a y that's bigger than 40, okay? So what's going on here, okay, is trying to think of the best way to explain this. So that limit to growth is going to happen when this stuff just like disappears and becomes 0, okay? So when this is gone, y is going to be 40. So a equals what? Not following? Okay, I'll just give it to you. Give it to you straight. The limit to growth is equal to a. This is just equal to a. Okay. So a equals 40. And then we can find what now with this? B. Yeah, we can find b now. So we have 10 equals 40 over 1 plus b, or 1 plus b times 10 equals 40, okay, or 1 plus b equals 4, or b equals 3. So there's our b, okay. And then we have B, we have A, we need what now? We still need C, right? How do you think we're going to find that? What do you think we use? We used our limit to growth, we used the initial value, what haven't we used?
Point.
The point, yeah, it contains 120. So just plug in literally everything you have now. So we're going to have 20 equals, we'll do this in pink. 20 equals 40 over 1 plus 3 times c to the x, and then we're just going to solve this for c, okay? So multiply both sides by the denominator, we get 20 times 1 plus 3c to the x equals 40. Divide both sides by 2, we get 1 plus 3c to the x equals 2. Subtract 1 from both sides. 3c to the x equals 1, or c to the x equals 1/3. And I'm sorry, I didn't plug in x. What do I plug in? What should I have plugged in for x? 1, yeah. So that's, instead of c to the x equals 1/3, it should say c to the 1 equals 1/3. So c to the 1 equals 1/3. You guys see how that popped out? So it's just a little bit of algebra, being able to solve for c. Okay, so I have all three pieces. So my, I'm gonna get rid of some of this. My final answer then is y. Plugging everything in, I get y equals 40 over 1 plus 3 times 1/3 to the x. That's it. Okay, that's it. All right. You feel okay about that? You feel okay? Good stuff, good stuff. Awesome, awesome. All right, B, okay? B, so I know initial value equals 16. Limit to growth is 128. It contains this point. Okay, so starting from our standard form of a logistic, what should I solve for? What do I know first, right off the bat? It's all right, that was Ben's timer. What do I know right off the bat? Yeah, good job. Yeah, what is that? Yeah, so A is the exact same thing as the limit to growth. It's 128. Yep. Yeah, he's all right. Yeah, Michael's on the right. He's on the right track. Yes, and then we use that. We plug that in. We get y equals 128 over 1 plus b, and then b times c to the x. Okay. So then, using our initial value there, so that means x right here. We're erasing x. X is going to be 0. We know that if we put the initial value of 0 in, we'll get 16. And now look what I have. I have an equation I can use to solve for b. C to the 0 is just 1. Okay, so 16 equals 128 over 1 plus b. Right, or 16 times 1 plus b equals 128. Okay. 128 divided by 16 is 8. So 1 plus b equals 8, or b equals 7. Okay. Just a little bit of algebra, a little bit of solving for b. So we have b, we have a. We need to just find what now? We just need c. How do we do that? Yeah, we use that initial, that point contains 5 comma 32. So we know 32 will be equal to 128 over 1 plus 7 times c to the 5. Okay, then we can solve this, solve that. Okay, so we have 32 times 1 plus 7 c to the 5th equals 128. Or 1 plus 7 c to the 5th equals 4, or 7 c to the 5th equals 3, or c to the 5th equals 3/7. Okay. You good?
Yeah, sorry.
No, you're good. All right, and then how do I get c by itself here? You raise both sides to the 1/3. So c equals the 5th root of 3/7. So I'm going to write it like this. That's my c right there. Okay, so we assemble all of it, we plug it all in, we get y equals 128 over 1 plus 7 times the 5th root of 3/7. All that raised to the x, okay? You seeing that? Okay, so just a lot of, this is actually a lot of plug and chug, I feel like. Yeah, you can go to the bathroom. Yep. Part C. So just looking, literally just looking at this graph, we're supposed to write the equation of this graph. How do I do that? So we just talked about how to do it when we're given these three statements. We're given an initial value, the limit to growth, and the point it contains. What are we given here? Does the graph give us the same information? Yeah, it does. So what's the initial value? What's that? Yeah, exactly. Yeah, good job. Yeah, so this point right here, this y-intercept, that gives us the initial value. Here's the initial value. Okay. That y equals 20. What is that? They drew a horizontal asymptote. Yeah, it's going to be the limit to growth. I'm going to highlight in orange. Okay. And I'll use that 2, 10 to find what? C. Yeah. It's the same deal. Same deal here. So we know a equals what? What does a equal? 20. And then plug all that in. So 5, plug in the initial value. So 5 equals 20 over 1 plus b times c to the 0. Okay, the c to the 0 goes away. We get 5 equals 20 over 1 plus b. Solve that for b. We get 5 times 1 plus b equals 20. We got 1 plus b equals 4. We get b equals 3. There you go. And then using that pink point here, I just plug everything in to find C. Okay, so 10, that's the y value at that point, equals 20 over 1 plus 3 times C squared. Alright, then I can solve for C. Okay, so I have 10 times 1 plus 3C squared equals 20, or 1 plus 3C squared equals 2, or 3C squared equals 1, or C squared equals 1/3. Okay. All right. So then C equals the square root of 1/3. It's the positive square root of 1/3. Which, when we rationalize our denominators, becomes root 3 over 3. Okay, so that's our C. Plugging everything in. Now it's just plugging everything into standard form. You get y equals 20 over 1 plus 3 times root 3 over 3 to the x. So any questions? Look, it's pretty straightforward. Okay, pretty straightforward. All right. If there's no questions, I might just move on to that word problem. Are you guys okay with that? Okay, I'm going to move on to the word problem. The spread of the flu. The number of students infected with the flu at Springfield High School. All right, anyone ever been to Springfield High School? All right, I haven't either. So it is given by this function, okay? All right, that's the function, okay? What was the initial number of infected students? How do you find that? What does that mean? Initial number. Anytime they ask for an initial number, you do what? Plug in 0 for what? T. So this becomes 0. What happens then when we plug in 0? This just goes away, right?
Yeah.
So that's your answer. 800 over 50. What's 800 over 50? What is that? 2. 50 times 2 times 8 is 16. So this is going to be P of 0 equals 800 over 1 plus 49 e to the, you good? Okay, take care, Ava. 0, that becomes a 1. We get 800 over 50, which is equal to 16. 16 students, 16 patient zeros. The initial number of infected students was 16. All right. B, when will the number of infected students be 200? What do we do here? What do we do? So did they give us P or T? T is time, right? T means time. Yeah. So the number of infected students is P. So we plug in 200 for P, and we solve for T. Okay, so let's solve this equation for T. So we see where the equation came from. I just plugged in 200 for P. Now we just got to solve that for T, okay? So let's multiply both sides by the denominator. We get 200 times 1.49 e to the negative 0.2 t equals 800. I'm going to divide both sides by 200 because I don't want to have to distribute. So 1 plus 49 e to the negative 0.2 t equals 4. Okay, subtract over the 1. We get 49 e to the negative 0.2 t equals 3. Okay. Now divide by 49, we get e to the negative 0.2 t equals 3 over 49. All right, I'm going to rewrite that with a finer pencil. So we have e to the negative 0.2 t equals 3 over 49. Okay, right here. Sweet. Anyone know how so I need to get t by itself, right? I need to get t by itself, okay? Where's t stuck? Stuck inside that exponent, right? How do I break t out of the exponent? How do I break a variable out of my exponents? What do I do? What do I do? Who said Ellen? Yeah, that's right, yeah. So to break the t outside of this e, right? So e is the exponential function, right? E is the exponential. What's the opposite? What undoes an exponential? Logarithm. Natural log. So we're going to do the log of both sides. What's the base of my log going to be? It's going to be the same as e. So the base of your log is going to be the same as whatever the base of the exponent on the left is. So e. So base e logarithm, that's called a natural logarithm, or ln. Okay. So what happens is that ln and that e, they cancel each other out, and this just becomes negative 0.2t. That equals ln 3 over 49. All right. And then divide both sides by negative 0.2. Okay. So we get t equals ln 3 over 49 all over negative 0.2. Right? So then put in your calculator. Luckily, nowadays we have calculators to do this with. Put in your calculator. You guys forget how to do logs in your calculator? Okay. All right, so I got my calculator here. I want to do natural log of 3 over 49. So what I do is I hit the ln button. ln, and then 3 divided by 49, right parenthesis, there you go. ln 3 over 49. Yeah, hit enter, and then we need to divide that by negative 0.2, right? So then divide by negative 0.2. There we go, about 14 days. So this is about 14. You see that? Wait for my please. Oh. All right, so about 14. Okay, just so we see it. So the curveball here was the natural log. When you got to break your variable outside, you have to break a variable that's inside an exponent, outside the exponent. You take the log of both sides, the logarithm, and the base for that logarithm is just the same thing as the base of this exponent. So the base of this exponent was e, so we did a base e logarithm on both sides, or ln. It's called ln, not Lawrence North. Okay, natural log. Can we do C now? C is actually a lot easier. Actually, no, sorry, I looked at another problem. So B, the answer was 14 days. Okay. The school will close when 300 of the 800 student body are infected. When will the school close? What do we do that? What's this one? What do we do for this one? What do we do for this one? So they're asking when, right? So they're asking us to solve for what? T. They're asking for when. So we're gonna plug in 300 for what? T. Yeah. Okay. Sorry. Misheard you. So it's gonna be 300 equals 800 over 1 plus 49 e to the negative 0.2 t. Okay, so same deal. Same deal. Okay. So 300 times 1 plus 49 e to the negative 0.2 t equals 800, or 1 plus 49 e to the negative 0.2 t equals 8/3, right? Because I divide both sides by 300, and I get 8/3. Okay. Subtract 1, I get 49 e to the negative 0.2 t equals 5/3. Okay. Divide both sides by 49, I get e to the negative 0.2 t equals 5 over, what's 49 times 3? 49 times 3 is 147. Okay. Alright, so I'm really close to solving for t. What do I need to do? T's stuck inside an exponent. What do I do? The log. Do the ln of both sides, yeah. Yeah. Okay, so ln, so then I know that I'm just going to keep going. I'm going to keep going a little bit below here. I know that negative 0.2 t is going to be equal to the ln of 5 over 147. So my final answer, t is going to be ln 5 over 147 divided by negative 0.2. Alright. You guys want me to show you how to do that in your calculator again?
Yeah.
Okay. So 5, this is 1 over 40. Okay. So ln of 5 over 147, we hit the ln button. ln, okay, of 5 over 147. Okay, enter. Okay, we divide that by negative 0.2. So 16 in about 17 days. 17 days. School will close in about 17 days. Okay. Is that okay? All right. So luckily we have calculators to do logarithms now. Back in the day, back in like the 18th century, they had to have tables to do their logarithms with. And so you would, I learned about it in college. You can, if you know like going from like so the logarithm of 1, log of 1 is always 0. So going from that, you can like get like the log of like 1.001. Right, you can just keep doing that. So they made like rows of tables that were like hundreds of thousands of lines long. But if you mess up on one line, then the rest of them are wrong. So if you messed up, you had to go back. Yeah. So back in the day. There's a lot of really cool books out there about like how they did certain things without calculators. Like finding like all the signs without calculators. All right. Can we do 7? Can we do 7? Yeah, let's do 7. We got plenty of time. Wait, what time does class get out? 15. All right, let's do number 9 then. Let's skip because 7's like almost identical. Population of Smallville. Anyone watch the CW? I just remember like back in 2004, all the commercials were for Smallville. All right, only if I stayed up past my bedtime. All right, population of Smallville in the year 1890 was 6,250. Assume the population increased at a rate of 2.75% per year. Okay? They want you to. Okay, this is an exponential growth. What's the general form of an exponential function?
Y equals A times B.
Yep. So what's my initial population? Yep, so what's that equal to? Which A is going to be equal to the same as my initial. Yeah. Yeah. So we know A equals 6,250. Okay. And then increase at a rate of 2.75%. What does that give me? Which letter that I need does that give me? It gives me my B. What's B equal to? What's B? If we're increasing at 2.75%, what do you multiply something to make it increase by 2.75%? You multiply it by 1.0275. Okay. So that's going to be 1.0275. Okay. So we have f of x equals 6,250 times 1.0275 to the x. That's my function. Okay. So to find what the population was in 1915, I plug in what for x? So if x is the number of years since 1890, then x should be 25. So this is going to be f of 25. 1940 is going to be f of 50. Okay, so f of 25 equals 6,250 times 1.0275 to the 25, and then you can do that on your calculator, okay? Same thing for f of 50. Are you guys comfortable doing exponential stuff on your calculator? Okay. All right, it's just just use the exponent button. Okay. And then predict when the population will reach 50,000. What do I do for that? They're asking me for a prediction of when. So I'm solving for t or I'm solving for p? I'm solving for t, so I'm plugging in 50,000 for p, right? So p, or for f, sorry. 50,000 equals 6,250 times 1.0275 to the x. Okay. All right, do 3.2 homework for Monday, please. Yeah. Isn't it pretty short homework usually anyway?
It's not.
Yeah, so show your grandparents precal or something. 8 equals. Oh, we did just graph it. Yeah. Thank you.
How long was the
What's
shit?
up?
Doing like a little boat, like the flags. How did it do if they were the main boat?
They probably get big. Yeah, they probably made the boat out like
Unless it's like about as possible.
You gotta keep your voice.
Hey, you kids have a good Thanksgiving, okay?
Do you have any fun plans?
I'm going to Cincinnati. Probably playing video games with my cousins.
Fun time.
My cousins are like high schoolers. Actually, yeah, my cousin's your age.
Oh, really?
Yeah, so I'll hang out with him. We'll hang out, talk shop. Not kidding, we'll talk shop.
You should watch the World Cup games on
Yeah, I don't know. It kind of leaves a bitter taste in my mouth. I don't like the slave labor stuff.
Oh.
I'm not like a huge social justice guy, but I don't know. At a certain
Okay,
point.
but you should support the U.S.
Yeah, I will. I'll vote for the U.S.
They're playing right now. That's why.
Oh, well.
Oh, good.
Dude, that's
Kids are taking the test next period, so they can't watch it. That was so funny. March Madness every year. I remember that. I remember like in the Reddit, kids do like have like their back like, on their iPad.
Here's the
Thank you.
Thank you.
Mm-hmm.
Have a good Thanksgiving.
You do.
You missed the review day, right? You want to take it tomorrow? What time did I say you can take it? What's your resource? So you don't have resource tomorrow. Have period tomorrow?
Friday. I'm stressed about this test.
No, you were gone for a while, right? Last week. Friday? Yeah.
Stuff taken here.
Where's Rocco? Oh. I might have forgotten about that.
Yeah.
Okay, should I get it?
You said no.
Yeah.
We don't have class tomorrow.
Just be one day late.
That's as long as I can get it.
All right. Let's get. Did you guys turn in the 2.8 homework?
Yeah, Friday. How many questions are there going to be from like this front page? Because the front page was.
I just didn't hear her do that. That's
Hour, an hour
Test in
day.
13
That
minutes.
one I would never do. It is.
Yeah, but it's a longer version. I was working my fastest. I only did it in 13 minutes. I had to make it short. I was gonna make it way shorter. It's not really that impressive. I've been doing this for a long time.
I know.
Like, what's your extracurricular? You're like show choir, right? You've been doing that for like a long time. You're like, you could like sing 10 times faster.
Yeah. But like math is just difficult.
For some people, for a lot of people, it is really difficult. But there are certain people, like, your personality's good for it.
Have you just like always been good?
Yeah, I would.
I mean, it's good skill to have.
Just very logical. I'm very rational.
And you do good at work.
Probably got done all.
I got like 10, 10.
We got bonus right there.
Dude, the football program
And each one is spend this year.
I don't remember what's my social.
Some people are very reasonable. They're very rational people.
It's tough for ACT.
You see my game this weekend?
we just practiced. We played against our other eyes.
I can have a good jump.
Yeah, it's not bad.
I've like never been to the church.
It's not bad.
You're a high jumper?
So
You're a high jumper. All those high gym kids. What's wrong with high gym? Chapter 3. That's the only. Hannah McCormick, right? Where'd you go to middle school? You know what's weird? Is when you guys were kindergartners, like, I would have been in 8th grade, so like some of my high school classmates would have been like your 8th grade buddy or whatever. Oh. That's kind of weird. Where you guys get to? I was at Harvard. Oh. Oh. People hate Harvard. I didn't go to, I defected. I came up here. Yeah, I'm a defect. He said it, not me. Alright, let's start this test.
I've been taking the quiz. Can I take the quiz today?
Yeah, take a quiz today. Alright, take your read packet out, please. And let's get your calculator out. Let's get a pencil out. Everything else away. Phone away, iPad away, smartwatch away. That's not it. Just use mine. So you take the other.
Yo, Mason.
Oh, it's my end of the day. You meant during beef. That works out perfectly.
Oh, what did I say? Oh, after school.
Yeah.
Never mind, it was in a different
Oh, you
pocket.
thought I meant after school.
Yeah.
I put it in a different
I
pocket.
said Jay. Help me with the. Wait, the math minor. I said Jacob.
What's that? Yeah, I heard.
I heard.
I like the country. Who is really coming?
By who?
What?
question. When, where, and how?
He's ready. He's trying to.
Right now, that's four. Okay, go ahead.
I'll take one away. I'll give you this. All right, Blair's going to take the calculus test. The rest of you, I'm start passing out the tests. Altitude tests. All right, you ready?
CG, right?
All right, you got the whole period. A lot of people finished it really fast, though. A lot of people. One person was done in like 15 minutes. I know. Like she was like, "I'm done." I was like, "What?"
He's transferring to the.
Yeah.
BS today, so.
What, I went here last year, and Westfield lost the year before that. And almost took your surprise.
You went to Center Road last year?
I went to Westfield.
Make sure you keep a lot. I wonder if we're getting like everything you want, right?
What? Mason, are you joking? Like, don't like.
No, like I
Don't
actually
play
don't
with me,
answer.
Mason. Come on now. You don't have any
Don't be a little stricter now. Come
He
on.
wants to be on a winning team. I don't blame him.
There you go. There you go.
Yeah, don't be a little stricter. Don't be a little stricter.
Mason, you're a little jokester today.
Hey, guys, please stop
Maybe
talking.
next year.
You got that one. There you go. Oh, you got it.
Yeah, it was in their pocket.
There you go. 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 Go. Stop talking, please. There you go. Good bud. New Balances. Fresh. Always. And then we approve when you let's get started. It's 35 and quit. I'll take attendance and I'll pray on your behalf. Oh shoot, I forgot to stop the video.